Okay, this is homework for Monday, March 14th. You're doing page 80 in the functions book, number 4 through 5. So number 4 talks about Justine floating down a river, and after 1 hour, they've floated 1.25 miles, 4 hours, 5 miles, and 6 hours, 7.5 miles. Is the relationship between time and hours linear? Okay, so the very first thing I always want to do is make a table when they give me values like that. So at 1 hour, so we have hours, and we have miles. So at 1 hour, they've floated 1.25 miles. And then in 4 hours, they've gone 5 miles. And in 6 hours, they've gone 7.5 miles. And now I can do my carets. The difference between 1.25 and 5 is 3.75. And the difference between 5 and 7.5 is 2.5. And then from 1 to 4 is 3, from 4 to 6 is 2. So I have to divide my change in y divided by my change in x. So 375 divided by 3 is 1.25, and then 2.5 divided by 2 is also 1.25. So that means there is a constant rate of 1.25 miles per hour. And I could have also gathered that from the situation because they said in 1 hour they've gone 1.25. So I was only checking that that was a constant rate at 1.25 because it could have been at some point they were going faster or slower. So even though they told me the constant rate because per hour they're going 1.25 miles, I still did a table just to make sure. So if it's linear, I'm going to say linear because going constant rate. And then it said write a function. So I'm going to do f of x equals, and then my slope, x plus 0. So now in order to get credit, I want you guys to make sure you label each of these things. So f of x, this would be total miles. My 1.25 is miles per hour. X would be hours. And 0 is at 0 hours. They have gone 0 miles. Hopefully you can read that. I know it got a little sloppy. Okay, number 2 is you and your friends are going BMX dirt biking. For one of the events, the competitors are going off a ramp. The winner of the event is the competitor that gets the most air, so that goes up the highest. Do you think the relationship between the weight of the bike and the height of the jump can be modeled by a linear relationship? So you got to think, if I have a bike that weighs less, that's like really light, will I be able to jump farther? So let's think about this in a graph. Okay, where I have weight down here and height on my y. So if my bike weighs a little bit, so it weighs just a little bit, am I going to be able to jump higher? Well, I would assume yes, because the less weight you have going into the air, the higher you could go. So it would start up here and go down. Then the heavier the bike weighs, the less you're going to be able to get, less air you're going to get. So it's going to be a negative relationship, negative linear correlation. Now, is it going to be like a perfect straight line? No, it might look something like this. But as long as I could put a line of best fit in there, and I can generally see that it's a negative correlation, then we can call it linear. So linear because the weight determines the height of the jump. Okay, so that's it for today. I will see you tomorrow. When I check your homework, I'm going to be looking that you have the equation for number 1 and it's labeled, that you wrote that it's linear and y, and then for number 2 that you wrote that it's linear and y.